everyone, Boyd King at OSUIT in the air conditioning department. I'm going to do a short video on the third of our motor segment. We've covered shaded pole motors, we've covered split phase motors with a centrifugal switch, and the third is a capacitor start induction run. Has a start capacitor, and we take out the start capacitor with a centrifugal switch. These motors, we find these in small open drive compressors. In first semester, if you had one of the older style refrigeration systems, it was an open type compressor. It was belt driven. We used a capacitor start induction run motor there. You see these on industrial fans, gear motors, things like that out in the field. This is a high starting torque motor and fairly, you could classify it as a lower or a medium running torque. It definitely has enough torque to start a compressor because we're using an increase in capacitance, which increases our phase angle shift for more starting torque. And then once just about any load, once it's up and spinning, you can continue the process through just an inductive type of motor. Okay, so remember I talked about both in shaded pole motors and split phase motors. The most important part of motors is understanding how they start. And so when explaining this motor, how it starts up, we can see the foundation, the platform that I told you we would be building on a split phase motor. We have a run winding and a start winding. Run winding has lower resistance, it's the fatter wire, and the start winding has the thinner wire, has more resistance. Because they have a difference in resistance, remember, a difference in current flow through the two windings, which creates a difference in magnetic fields. And that phase angle shift is where you get a sense of direction and starting torque. Okay, so this is going to be the first motor that we talk about that uses a start capacitor to increase starting torque. An electrolytic start capacitor, we can identify it because it's a black plastic, usually round, higher microfarad capacitor. This is a 220 microfarad capacitor, and what's significant to remember about start capacitors is we cannot leave them in the circuit. We have to take them out of the circuit from 1 to 3 seconds. And so during startup, we have to use some type of switch to take out the start capacitor. Now, whenever you're first starting to learn motors and you learn the capacitor start induction run motor, a lot of students will always want to hang on to the fact that when a centrifugal switch takes out the start capacitor, it is true in this particular motor that the centrifugal switch, when it gets up to speed, is going to take out the start capacitor and the start winding. But that's not going to be the case in all motors. We're going to get into capacitor start, capacitor run motors and use current relays and potential relays later on to take out the start capacitor but leave the start winding in the circuit. This is not the case here. That's where the induction run comes in. How this motor starts and runs is like this. At startup, we have current flow through the run winding. It's right across the line. Current flow through the start winding in series with a start capacitor, in series with the normally closed centrifugal switch. Because the centrifugal switch is normally closed, that phase angle shift, it allows current to flow through the start winding, creating the phase angle shift. And when we add a capacitor in series with the start winding parallel to the run winding, it increases phase angle shift even more for more starting torque. So we get up to 75 to 80% of our total speed. The centrifugal switch opens, and in a capacitor start induction run motor, that centrifugal switch opens. Since the start capacitor and the start windings in series, it takes them out of the circuit, and it runs simply as an inductive load, one winding only. So that's where high starting torque at startup, start capacitor in series with the start winding, a lot of phase angle shift, a lot of starting torque, but once it gets up to speed, as soon as the centrifugal switch opens, the start capacitor drops out of the circuit. That's going to happen within a second. Okay, I always describe it. You'll hear a sound, and that at the beginning, is with the start capacitor in the circuit. So capacitor start opens up, and then it runs as an inductive load. Okay, so I'll add some questions to this. Try to make a video quiz out of this. Please email me, keep up with your lessons, and we'll see you next time.